Hello calculus students, and welcome to the final video here on the lesson on volumes of solids with a known cross-section. And so here we deal with a particular problem with a solid that has a base bounded by y equals x squared and y equals x. So I've already drawn in these two functions, these curves, to save us a little bit of time. Now the key here that makes this problem a little bit different, there's actually two things. One is that we have a rectangular, cross sections. The base of each rectangle is perpendicular to the x-axis, so that's the base. Now the height of each rectangle varies. So the height of these rectangles, I'm going to draw this in a very weird way. It sticks out like this, but each one of this depends on the value of x. So when x equals 1, the value of the height of the rectangle is 2. The base is whatever this line is. And when x equals 1/2, for example, the height that sticks out here would be 1 rather than 2. So if you are closer to the origin, if x is smaller, then the rectangles are shorter. And if you go all the way out here, then you have your base right here, which is a smaller base, but a taller rectangle. And then you're kind of just stacking. You're just kind of stacking all of these rectangles next to each other until you fill up this region, and we figure out what is the volume of that. So I found this intersection here. This is 1, 1. Keeping it simple. So the volume is equal to the integral from 0 to 1. Now we're going to integrate along the x direction because these lengths here, these bases of the rectangles, are perpendicular to the x-axis. So we're going to add up an infinite number of them in that direction. And what we have here is just a formula for the area of rectangle is base. I'll use b times height. But because we're integrating along the x direction, everything has to be converted into terms of x. So the volume is equal to the integral from 0 to 1. Now the base here is just the distance between the top curve and the bottom curve. So I'll write a note on the side here. The base is equal to x minus x squared. It's just this length from the top curve to the bottom curve. And the height is equal to 2x. That was given to us. So it's not too difficult. X minus x squared times 2x dx. So maybe we can simplify this a little bit further. This is from 0 to 1 of 2x squared minus 2x cubed dx. I really should just pull this 2 out of the front here. So this is x squared minus x cubed dx. So this becomes, I'm running out of space, so I just use this here, 2 times 1/3 x cubed minus 1/4 x to the 4th, all evaluated between 0 and 1. So this is 2 times, what is that? That's 4 minus 3, so 1/12. So this all comes out to a volume of 1/6. All right, so there you have it, the final answer to this problem. And again, it's important to kind of reflect back on all 4 of these examples that we did and try to understand what makes them a little bit different and where in the future we will use each of these different methods. As we go forward, whether you're taking the AP exam or not, we want to be able to apply these concepts in different contexts. So hopefully I presented the tools here to you well, and you're able to sharpen them. And we'll look at some examples together in our discussion and our work to see how we can apply them to solve some very practical and interesting problems. Thank you for watching again. As always, ask if you need help. Have a wonderful day.